In this question, we're told a factory manufactures cups. The manager knows from past experience that 5% of the cups produced are defective. Given a random sample of 50 of these cups, determine the probability that the number of defective cups in the sample is part A exactly 2, part B between 3 and 8 inclusive. Okay, so the first thing to notice in this question is that we have a binomial distribution. The way we identify this is we're given a number of trials. It's this random sample, so we've got n equals 50, and we're also given a win, lose, fail, succeed, defective or not defective situation. So start off by declaring that x equals number of defective cups. Okay, so we need to declare what the random variable is, and then we need to state that x is distributed binomially where n is equal to 50. And the probability of it being defective is 0.05. And that's the first part of our question. So that's A, this is part I. So we can then answer probability that x is equal to exactly 2. We can use the binomial formula. N choose x, so 50 choose 2, times the probability of it being defective, 0.05 to the power of 2, times the probability of not being defective, 0.95, so there's the remaining number of cups, which is the power of the remaining number of cups, which is 48. Now if you work through that on your calculator carefully, you should get an answer of 0.261 to 3 decimal places. Okay, part 2 says to find the probability that there is between 3 and 8 defective cups inclusive. So we're saying probability 3 is less than or equal to x is less than or equal to 8. Now the way we calculate this is I need to calculate the probability of having up to 8 cups defective, but then I don't want the probability of it being 0, 1 and 2 cups defective, so I'm going to subtract probability of x less than or equal to 2 from this. So let's have a look at this and take these readings from the table. So here's a sample of our table. We are looking for the column where the probability is 0.05, so I'm just going to highlight just a line to the right of it so we can follow where we're reading up to. And so first of all I want probability x is less than or equal to 8. So reading across from 8 we get an answer of 0.9992. So let's just record that, 0.9992. Take away. So now we want to find the probability x is less than or equal to 2. So probability x is less than or equal to 2, just reading across here, you can see it's 0.5405. So going back, 0.5405. And so finally, if I finish off this by completing that subtraction, we get an answer of 0.4587. Okay then, so let's just quickly mark this before we have a look at part B. So first of all, standalone marks given if you've identified that x is the number of defective cups and it's distributed binomially, as I have done. There is then in the second part a method mark for correct use of the binomial formula and an answer mark for getting 0.261. And then in part 2 there's a standalone mark for the reading for x less than or equal to 8, standalone mark for a reading of x less than or equal to 2, and a standalone mark for the answer 0.4587. Okay then, so let's have a look at part B and see what part B says. Part B says the factory also manufactures plates. The manager knows that 1.5% of the plates produced are defective. Use an appropriate Poisson distribution to find approximately the probability that a random sample of 250 of these plates contains exactly 4 defective plates. So in this question, let's use a different variable because we've already used x for the number of defective cups. Let's use y for the number of defective plates. Again, start by stating this. Y equals number of defective plates. Now, again, what we want to do is we want to start off just by identifying that y is distributed binomially. This time the number of trials or the sample is 250, and the probability of it being defective is 0.015. Now this can be approximated by the Poisson, so y distributed with Poisson, where the mean is given by 250 times by 0.015. So in fact what we're going to do, because we're using a Poisson approximation, is we're going to say y is distributed with Poisson mean 3.75. Okay, in the question it asks to find the probability that exactly 4 of these plates are defective. So because it's exactly 4, I would use the Poisson formula anyway. But because of the mean, you'll find that you'd have to use the Poisson formula. So just remember, we've already seen the Poisson formula. Probability x is equal to x is given by e to the minus lambda times by lambda to the power of x all over x factorial. So I get probability x is equal to 4. Will give me e to the minus lambda, which is 3.75, times lambda, which is 3.75, to the power of x, which is 4, all over 4 factorial. And so if you type that into your calculator carefully, just take care, make sure you're showing all your working, you get an answer of 0.194. Okay, so let's have a look to see how you get the marks in this part of the question. First of all, there's a standalone mark for getting the correct Poisson distribution. Next, there is a method mark for the use of the Poisson formula. And finally, there is an answer mark for the correct answer for the probability of x equals 4. Okay, well I hope you were able to follow my solution and that you understood how to mark the question.